Interpretation of laboratory results. Look at your downloaded course materials, section 17, and we see here an example. We're using ProLab, a report from ProLab. And a laboratory report should include a laboratory's letterhead to identify the laboratory, and it should bear the signature of a quality assurance manager of some type. The laboratory report typically consists of 3 parts. The first part contains the identification of the mold spores collected. Here, page 2, is a table listing spore identifications and counts. Very easy to read. Page 3, it's very nice, a colored bar chart identifying spores and counts. This is really great for your client and for yourself. It's very easy to understand. The second part contains general characteristics of mold with respect to the most common impact on human health. Many types of mold have species with varying characteristics. This report from ProLab contains very good general information about indoor air quality testing, mold testing methods, data interpretation, and symptoms of mold exposure. This information continues from page 4 to 8, as you can see. So scan through to page 9. This is a list of references and resources if the receiver of the laboratory report would like further information. The third part of a typical laboratory report should include a concluding report summary. The summary from ProLab here in this report is located on page 10. Every laboratory report should indicate whether the analysis suggests that unusual mold conditions exist or not. This determination is based upon the type of mold detected in the samples. For air pump samples, the type of mold as well as the inside and outside counts are considered. This report states 1 or more of the samples in this report indicate the presence of elevated indoor mold spores or colonies for these specific locations only. Professional advice will be necessary to determine the appropriate actions to take to correct the conditions indicated. Here are some guidelines for interpreting laboratory reports. There have been studies of mold in homes that have provided new information about what is normal or unusual in a healthy home. Every building has mold, but deductions may be made about whether a particular building has unusual conditions or levels that may necessitate further investigation. Air samples should be evaluated by means of comparison, indoor to outdoor, and by fungal type. In general, the level and type of fungi found should be similar, indoors as compared to the outdoor air. Differences in the levels or types of fungi found in air samples may indicate that moisture sources and resultant fungi growth may be problematic. Simple confirmation. The information expected from contact surface samples is often simple confirmation that the collected material was biological in nature, or that the biological growth can be ruled out. Mold growth is inappropriate. Many fungi produce allergens, and some fungi produce toxins. Fungal growth in buildings, therefore, is not desirable. Fungal growth may cause health problems for building occupants. Mold growth in a building is inappropriate and should be removed. Steps should be taken to correct conditions that led to the mold growth so that it doesn't occur again. Visible apparent mold that is confirmed by a surface sampling to be actual fungal growth is evidence of indoor contamination. Air sampling may indicate indoor fungal growth that is either visible or possibly hidden. Visible apparent mold, mold-damaged materials, and moldy odors should not be present in a healthy building. When a swab, carpet, tape, or even bulk sample contains spores of any mold, then the report should indicate that unusual conditions exist. Health effects. It is not the mold inspector's responsibility to establish that mold exposure to mold spores occurs or that exposure is a health hazard to their client. Information on cause-effect relationships between biological materials and illness is not currently available. Should be similar. The kinds and concentrations of mold and mold spores in a building should be similar to those found outside. In cases in which a particularly toxic mold species has been identified or is suspected, a more cautious or conservative approach to remediation is indicated. If an air sampling shows that the types and concentrations of mold in indoor samples are not similar to those in local outdoor air, then there is a mold problem in the building. If indoor concentration levels exceed the outdoor levels, or when the types of mold inside differ from those outside, then there is a mold problem in the building. Once the mold problem is identified and the mold remediation is complete, then the type of mold and the concentration levels of mold should be similar. After remediation, the types and concentrations of mold in indoor air samples should be similar to those in local outdoor air. Elevated indoor levels. When an air pump sample of a building interior contains more mold spores than an outdoor air sample, then the report should indicate that elevated conditions exist at the building and that the levels may necessitate further investigation. Sampling results. Hypotheses should be answered. Mold inspectors should consider the results of the sampling, surface and air samples, in conjunction with the building's condition to decide if the information supports the hypotheses that have been developed and if the information warrants a recommendation for mold remediation. In general, immediate remediation is needed for microbial growth found on materials that are in direct contact with indoor air or subject to disturbance that might release biological particles, as well as for materials that building occupants may contact directly. If sampling cannot be done properly and enough samples to answer the client's concerns cannot be taken, then it is preferable not to sample at all. Inadequate sample plans may generate misleading, confusing, useless results. Samples should be analyzed according to the analytical methods recommended by the American Industrial Hygiene Association, AIHA, and the American Conference of Governmental Industrial Hygienists, ACGIH, or other professional guidelines. There is a resource list in your course materials. Keep in mind that mold sampling provides information only for the moment when the sampling took place. For someone without experience, sampling results will be difficult to interpret. Experience in interpreting results from laboratories is essential when communicating to your client. Threshold limit values and guidelines. Threshold limit values, TLVs, refer to air concentrations of substances and represents conditions under which it is believed that people may be repeatedly exposed day after day without adverse health effects. There is not sufficient information available. There are no mandatory limits against which inspectors can compare measurements of air or surface sampling concentrations related to health effects to mold exposure. Data on the range of inhalation exposures to mold are limited, and the methods that inspectors use to collect and analyze microbial growth, mold, vary widely. Even if limits were set, they would be arbitrary standards because the data on the cause and effect of mold exposure on which to base mold exposure limits are few and inconsistent. The problem lies in the fact that biological exposures are often very complex mixtures of variable composition. Qualitative and quantitative information about mold or biological exposure and health effects is often imprecise because biological material, other than those intended to be sampled, may be present and responsible for some of the health systems manifested by the exposed person. Although the issue of whether exposure to indoor fungi causes adverse health effects is controversial, there's no doubt that a seriously mold-contaminated building can suffer structural damage and that a foul-smelling, fungus-filled building is aesthetically unpleasing. Controversies about health effects aside, the latter two concerns are sufficient to merit a complete mold inspection and remediation when an environment is found to have fungal contamination. People who have concerns about structural damage or aesthetic effects of indoor fungi should seek the services from a certified mold inspector. People who have concerns about health effects of mold exposure should seek the counsel of a healthcare professional. Mold inspection reports. Every mold inspection report should contain some minimal stuff. Every mold inspection report should contain information in a format that is useful to the person who needs the results. Scope of work, property information, visual examination, sampling, and laboratory results should be included in any mold sampling report. Scope of work. Scope of work should list all of the hypotheses, concerns, assumptions, and a description of the sampling that was performed in order to test them. It should refer to the standards of practice, IAC 2, mold sampling standards of practice. Another thing that should be in the mold report is property information. This should include the property address, the size and age of the building, number of occupants, and the date of the inspection and time of the inspection. The weather conditions should be included as well. Visual examination section of the report. The systems and components of the building that are inspected should be listed here. Each system and component inspected should be identified with a description. The report should include any moisture intrusion, water damage, apparent mold growth, musty odors, and conditions to mold growth. And a summary of the visual examination should be listed. Sampling. The instruments and devices used in the collection of samples should be listed and described in the inspection report. The sampling locations and areas of the building should be recorded. Digital pictures really help. The laboratory results should be included with your report. Don't copy-paste from the laboratory documents. Leave the letterhead there. Just include it as an attachment at the end of your inspection report if you'd like. A summary of the laboratory results could be written in the report. Interpretation of the results and recommendations should be confined to those that are supported directly by data obtained during the visual examination and sampling. Determination of patient sensitivity to fungi and the assessment of the relationship between that sensitivity and the symptoms should be determined by a healthcare professional who is possibly guided by the results of your certified mold inspection report. It is not the inspector's responsibility to correlate mold in a building to the client's health. Let's talk about remediation, because remediation is the goal of the results of the mold inspection. If there's areas of concern, water moisture And if there's mold growth, evidence of mold growth, then the next step is to recommend remediation. A mold inspector has to be knowledgeable about what takes place in remediation in order to communicate to their client from beginning to end the process of experiencing a mold inspection. Mold should not be permitted to grow and multiply indoors. Problems associated with mold have been around since recorded history. Solving mold problems requires the fixing of the source of the moisture and removing any contaminated components. In remediation, you have to dry quickly. Dry items before mold grows if possible. Mold can grow instantly if there is adequate temperature, moisture, and food provided. Carpeting that's wet. Dry the carpeting immediately, at least within 48 hours. Don't let it go over 2 days. Remove the water with a wet vac. Pull the carpet up and pad off the floor and dry them using a fan to blow air over them. The wet vac can be rented at your local home center, and also the blower fans too. Vacuum up that water. It takes a long time. Go back and forth in different directions, especially the corners along the baseboard edge. And then the carpet, if there's carpet and padding, you can pull that up. You don't need special tools or a carpet kicker, maybe to put it back in place. Just pull it up enough in a corner somewhere to get that blower fan underneath, and then turn that blower fan on. Don't step on the carpet. The carpet ideally would start to float up. It'll bubble up and down and wave. Try to blow above the padding and then lift the padding and try to go under the padding. And get multiple fans. One usually doesn't cut it, because when you're trying to dry out one area, you're leaving the other wet areas behind. So you have to dry it out quickly. And it really works. The incorporation of a dehumidifier in this drying process is fantastic. While fans are being used, the dehumidifier could be collecting any moisture in the air and taking it out with a bucket. Water can be removed from concrete or cinder block surfaces with a water extraction vacuum. Using dehumidifiers, fans, and heaters can accelerate the drying. Hard surface flooring such as linoleum, vinyl, ceramic tile should be vacuumed or damp wiped with a mild detergent and allowed to dry. They should be scrubbed clean if necessary. If the underflooring is wet, it should be dried using a vacuum or by exposing it to the air. Non-porous, hard surfaces such as plastics, metals should be vacuumed or damp wiped with water and some mild detergent, that's all, and then allowed to dry. Scrubbing may be necessary to thoroughly clean surfaces. Water should be removed from upholstered furniture with a water extraction vacuum, really powerful wet vac. Completely drying upholstered furniture within 48 hours may be difficult. So if the piece is valuable, you may consider consulting a restoration or water damage professional who specializes in furniture. Drywall may be dried in place if there's no obvious swelling and the seams are still intact. Otherwise, removal of that drywall is necessary. The wall cavity is the most difficult area to dry, and it should be ventilated if drywall is left to dry in place. Drywall traditionally is made from the mineral gypsum with a layer of heavy paper on the outside and inside. Commercial gypsum boards and drywall are also available with a variety of outside layers and coatings. According to the U.S. Geological Survey, a typical new home contains more than 7 metric tons of gypsum only. To clean water-damaged window drapes, follow the manufacturer's laundering or cleaning instructions. That's easy to do. To clean wooden surfaces, remove the moisture immediately and use dehumidifiers, fans, and gentle heat to dry them. Be careful of hardwood floors. Don't want to heat those up. Some water-damaged items, such as ceiling tiles or fiberglass insulation, drywall, books, and papers, have to be thrown out. If valuable or important books or documents or other items are moldy or water damaged, a consultant about restoration and water damage and remediation may need to be hired. Before a remediation project is planned, the size and extent of the mold problem and any continuing moisture problems have to be addressed or measured. Remediation can generally be divided into small, medium, and large. Small being below 10 square feet, medium 10 to 100 square feet. Anything over 100 square feet is large and requires safety professionals and professionals experienced with health and safety and mold exposure and a remediation manager. Your client will probably ask you, what should I do if I find this stuff on my own? Well, in your course materials, there's some remediation guidelines or recommendations. Let's go over some of them. A wet vacuum. Wet or water extraction vacuums are designed to collect water. They can be used to remove water that has accumulated on floors, carpets, and hard surfaces. Wet vacuums should be used only when materials are still wet, otherwise they may spread the mold spores. Wet vacuums alone will not dry carpets. Wet carpets must be pulled up and dried and then reinstalled. The carpet padding must also be dried. The tanks, hoses, and attachments of wet vacuums should be thoroughly cleaned and dried after use because mold and mold spores are sticking to the surfaces. Damp wipe. Mold can generally be removed from hard surfaces by wiping or scrubbing with water and mild detergent. That's it. Always follow the cleaning instructions on the product labels. Surfaces cleaned by damp wiping should be dried quickly and thoroughly to discourage further mold growth. Porous materials that are wet and have mold growing on them may have to be discarded because mold will infiltrate porous substances and grow on or fill in empty spaces or crevices. Completely removing mold can be difficult, if not impossible. Mold can also cause staining and other cosmetic damage. HEPA vacuums, high-efficiency particulate air vacuums, are recommended for the final cleanup of remediation areas after materials have been thoroughly dried and contaminated materials have been removed. HEPA vacuums are also recommended for cleaning up dust that has settled outside the remediation area. When changing the vacuum filter, workers should wear PPE to prevent exposure to mold that has been captured in the vacuum. Throw away damaged materials. Mold-contaminated building materials that cannot be salvaged should be double-bagged in 6 mil or thicker polyethylene plastic bags. The bagged materials usually can be discarded as ordinary construction waste. Packaging mold-contaminated materials in sealed bags before removing them from the contaminant area is important to minimize the spread of mold spores throughout the building. Large items that have heavy mold growth should be covered with polyethylene sheeting and sealed with duct tape before removed from the contaminated area. Floods. Buildings that have been heavily affected by floodwaters should be assessed for structural integrity and remediated by experienced professionals. Note that the information covered in this course was developed for inspecting for mold and moisture conditions caused by clean water, water intrusion from the ground or the rain, or a plumbing leak, not flood water or sewage or other contaminated water. During a flood cleanup, the indoor air quality in the home may appear to be the least of your problems. However, failure to remove contaminated materials and reduce moisture and humidity can present serious long-term health effects and risks. Standing water and wet materials are a breeding ground for microorganisms such as viruses, bacteria, mold. They can cause disease, trigger allergic reactions, and continue to damage materials long after the flood. Buildings that have been heavily damaged by floodwaters should be assessed for structural integrity and remediated by experienced professionals. Be cautious doing a mold inspection when the building has been affected by floodwaters. Remediation in HVAC systems. Mold remediation involving heating, ventilation, and air conditioning systems should be done by professionals experienced in working with HVAC systems. Professionals may have several different methods and techniques for approaching HVAC remediation work. As with the rest of a mold inspection project, professional judgment is required when working with HVAC systems, and professionals may use materials, methods, and techniques not mentioned at all in this course. An HVAC system found to be contaminated with mold should be turned off and not used until the system has been remediated. Using a mold-contaminated HVAC system may spread mold throughout the building and increase the exposure of building occupants. There may be some exceptions for instances when all or part of the HVAC system can be run based on a professional judgment if there is no risk of increasing occupant or worker exposure. If possible, the HVAC system should be remediated during off hours when the building is not in use, but in a residential environment, that's usually not the case. During remediation, effective containment of the area served by the ventilation system is important to avoid the spread of mold and mold-contaminated materials. All intakes and supply vents will be sealed up with plastic and tape. A negative air pressure will be maintained in the work areas, a fan being used. Contaminated porous materials in the HVAC system will be bagged and removed. Materials that can be cleaned will be vacuumed with a HEPA vacuum or cleaned with a moist cloth and detergent solution. And all the items will be dried as soon as possible, promptly. When you find mold contamination, medium, large, in a crawl space, underfloor crawl space, you'll be asked, even though you're not qualified to answer these questions, you'll be asked about remediation and how it's going to take place. The air in some confined spaces, like a crawl space, may be contaminated, posing significant health risks for the workers that are going inside to remediate the mold growth that you found. Because exposures may greatly be magnified in a confined space, like a crawl space, workers must use higher level of PPE than they would when working somewhere else in the home. Worker safety must be carefully considered when deciding whether to use disinfectants or biocides, because confined spaces can increase the potential for exposure. In general, work in confined spaces should be conducted only by trained professionals who have the equipment required by OSHA to deal with the inherent dangers of this type of environment. Before remediating mold in a crawl space or a confined space, the area should be evaluated for atmosphere and toxic substances. If there is any chance of low oxygen, the area should be tested using the appropriate equipment, and the testing equipment should be kept on site and used periodically to ensure an adequate oxygen supply. If the area is sealed off from the rest of the building to prevent the spread of mold spores, oxygen testing should be conducted again after the area has been sealed. Once the hazards have been identified, say in the crawl space, procedures for working in the confined space should be included in the remediation plan. Special consideration should be given to all those who will be allowed into the area, how communications will be maintained, what materials can be taken in or used in the space, and what safety equipment is necessary. It's some serious stuff. Only individuals trained in the hazards associated with that space should be allowed to enter. An attendant should be posted outside of the confined space area to summon help if necessary. The area should be well lit so that work can be conducted efficiently and injuries avoided. In conducting the mold remediation, every effort should be made to keep dust and mold out of the air. This can be done by using moist techniques such as damp cloth or pad for removal, and by bagging the material in the confined space and later removing it. Mold levels are likely to be high in a confined space, so PPE should be selected accordingly. Most cases will require full PPE, including skin and eye protection, full respiratory protection using a full face respirator or a powered air purifying respirator with a HEPA filter. The presence of asbestos may also require PPE for workers as well as monitoring and medical evaluation. You may be hired to inspect a building after remediation is complete. How do you know when you have finished the remediation in a complete and professional manner? Well, ultimately, it's a judgment call. People should be able to occupy or work in the building without health complaints or physical symptoms. The most important action, if mold growth is to be controlled in a building, is to eliminate the source of the moisture that caused the mold problem. No matter how good the mold cleanup is, if the water problem isn't solved, mold will return. Ideally, the mold inspector who clears the contamination remediation project is the one who found the source of the moisture problem, so that you can follow the process all the way through. Determining whether moisture in the building is being controlled is the key in assessing the effectiveness of the remediation effort. If moisture is not being controlled, even removing all the mold growing in the building will only be a temporary solution. A visual examination of the area that has been remediated should show no evidence of present or past mold growth. There should be no moldy or musty odors associated with the building, because those odors suggest that mold continues to grow. If mold or moldy odors are present in the building, you know that the remediation effort has been ineffective. Keep in mind that remodeling, cleaning, and construction may have introduced new building materials or chemicals capable of causing upper respiratory irritation that in some individuals may mimic the symptoms caused by the exposure to mold. How do you know that the remediation crew has completely fixed the mold problem? Well, they should have completely fixed the water and moisture problem. They should have completely removed the mold in the house. Use professional judgment to determine if the cleanup is sufficient. Visible mold or mold damaged materials and moldy odors should not be present at all. If you have made some samples, the kinds and concentrations of mold and mold spores in a building should be similar to those found outside once cleanup activities have been completed. Revisit the site shortly after remediation. It should show no signs of water damage or mold growth. People should be able to occupy or reoccupy the space without health complaints or physical symptoms. Ultimately, this is a judgment call. There is no easy answer. In a mold inspection report, I like to include what my client can do to prevent mold growth. Keep the building and furnishings dry. When things get wet, dry them quickly. Perform routine maintenance, cleaning, and repairs. The key to mold prevention is moisture control. Water entry into a building or building crawl spaces should be controlled. If water enters a building through a leaking roof or because of a flood or an accident, it should be removed immediately and affected areas should be dried out. Hidden areas. Special attention should be given to areas that are hidden and that might have gotten wet. Areas behind walls and in ceilings and crawl spaces in attics are frequently overlooked by building occupants and not dried carefully. In general, all wet areas should be completely dried within 48 hours to prevent mold from seriously growing. Routine maintenance is important. A number of items frequently involved in mold problems should be checked and maintained routinely. Furnace humidifiers must be cleaned regularly to prevent mold and bacterial growth. Ducts in which humidifiers are installed should also be checked to ensure water has not leaked into the furnace or filter areas. Standalone humidifiers should be cleaned very frequently to ensure that they are not moldy. Special attention should be paid to any filters in the humidifier because they can become moldy and the humidifier can spread mold spores throughout the whole building. Carpeted areas around humidifiers should also be monitored for wetness. Humidifiers should be set to produce less than 60% relative humidity in the building. Relative humidity greater than 60% is likely to result in condensation in the building, which can lead to mold growth. HVAC systems should be checked routinely because mold in a ventilation system may spread throughout the building. Drain or condensate pans should be also checked routinely because they can become reservoirs for mold and bacteria if not installed properly and maintained properly. These pans are designed to remove water produced by cooling hot air from the ventilation system. If the pans do not drain or are not cleaned frequently, they may allow water to enter the HVAC system and contaminate the ventilation ducts in the building. The pans themselves may grow mold and allow mold spores to be spread throughout the building. Filters for the HVAC system also should be kept dry and changed frequently. Toilet and bathroom areas should be carefully monitored for water and plumbing leaks. Rippling wall coverings, cracked drywall tape, peeling paint, and other signs of water damage should be investigated quickly. These signs frequently indicate that water has leaked and hidden mold growth and damage are likely. Water seepage into crawl spaces or basements should also be stopped quickly to ensure that mold will not grow, and measures such as the installation of sump pumps or a regrading of the area around the building should be considered to prevent future leaks. Any areas that smell moldy or musty should also be investigated to ensure that water has not entered and mold is not growing. Buildings should be located, landscaped, built, and renovated with the consideration for the climate. A building that is not suited to the climate can have moisture problems. Buildings inevitably will get wet, both inside and out, and they must be allowed to dry or mold will grow in them. Selection and location of building materials and furnishings can also be made with mold prevention in mind. In frequently damp or wet areas, more mold-resistant materials can be used. For example, some woods are more resistant to mold than particle board or pressed board. Give your client mold prevention tips. Clients love tips. Moisture is the key. Keep the building clean and dry. Dry, wet, or damp areas within 48 hours at most. Fix leaky plumbing and leaks in the building envelope as soon as possible. Watch for condensation and wet spots. Fix the sources of moisture problems as soon as possible. Prevent moisture due to condensation by increasing surface temperature or reducing the moisture level in the air, the humidity. To increase surface temperature, insulate or increase air circulation. To reduce moisture level in the air, repair leaks and increase ventilation if outside air is cool and dry, or dehumidify if outdoor air is warm and humid. Keep the heating, ventilation, and air conditioning, HVAC, drip pans clean, flowing properly, and unobstructed. Vent moisture-generating appliances such as dryers, even electric ones, to the outside where possible. And maintain low indoor humidity, below 60% relative humidity, ideally 30 to 50% if possible. Perform regular building and HVAC inspections and maintenance as scheduled. Don't let foundations get wet. Provide drainage and slope away from the foundation. And I would tell my client, if they are not experienced with home building and repairs, they may want to consult a professional, a handyman, to make repairs, or for assistance with mold prevention related changes to the home or their building. Pollen and mold counts. The American Academy of Allergy, Asthma, and Immunology, AAAAI, organized the Aeroallergen Monitoring Network, which has compiled pollen and mold counts for more than 30 years. The network was established to further the science of allergy and to contribute to the information available to physicians for the diagnosis and treatment of allergic disease. The network has reported pollen and mold spore counts to the public and media since 1992 through the National Allergy Bureau, a service established by the AAAAI. Member stations report pollen and mold counts to the NAB, which releases reports to the interested media outlets and to the public through the AAAAI website at www.aaai.org/NAB. Results are reported as total tree pollen, grass pollen, weed pollen, and mold spore counts per cubic meter, with comments about their relative amounts. This information allows allergy sufferers and their physicians to correlate symptoms and causing agents. Accurate forecasts of future counts would allow people to adjust activities on days with predicted high counts. Forecasting involves having accurate counts from previous years at the involved site and taking into account meteorological data. Researchers involved with the network are working on such predictive models, but want to improve their reliability before making such predictions available to the public. Until reliable forecasts are available, people with symptoms will have to rely on trends in recent high pollen counts to alert them to take appropriate precautions regarding avoidance. Go check it out, aaai.org. In your course materials, there are some vital documents that we can go over. First one is a work ledger or a logbook. A work ledger is a small book used by an inspector during a visual examination and a sampling of a building. During a visual examination of a building, notes can be written down in the ledger and then transferred to the inspection report at a later time. Answers to questions that were asked of occupants could be written down or jotted down and recorded very quickly. Sketches of the floor plan of the building or the room can be written down or drawn in the ledger, and then that information can be later transferred to the inspection report. During a sampling, records of sampling location, sampling time, sample identifications can be recorded in the ledger. The air pump shall be calibrated on a regular basis, and pump calibrations should take place once on every day that you have an inspection to perform, preferably in the morning before any sampling takes place, and that data of the calibration should be recorded in the ledger. This ledger is actually a legal document that can be of great value to you if there are any legal investigations about your mold inspections. The first two questions someone might ask you as a mold inspector during a legal investigation may be, when did you calibrate your pump machine? And can you prove it? You pull out that ledger. Clear and complete records of where a sampling took place, what type of sampling device was used, when the pump was turned on and off, what the airflow rate was at the time of the inspection, and unique identification of the sampling devices are necessary to compile an accurate report and to respond to possible litigation. Sampling information a mold inspector may desire to record in a ledger may include the collector's name, yourself, date and time of the sample collection, address of the building, sample identification numbers, sample type, sample collection site, a sketch or a map or a drawing. Also take a photograph. The people present at the time of the inspection can be recorded in the ledger. Sample transportation method and conditions, sample storage conditions, type of analysis requested at the inspection, you can write that down. Date and time samples were retrieved at the laboratory. Sample device, sample manufacturer name, sampling pump identification numbers that were used in a particular area at a particular date and time, sampling airflow rates, volume of air collected, weather conditions, wind direction, general velocity, temperature of the air, temperature of substrates. An enormous amount of information can be recorded in your work ledger. In the vital documents, you should have on hand somewhere, you can include it with your inspection report, the IAC2 mold inspection standards of practice, which include the sampling procedures. Another vital document that's listed in this section of your course materials is the InterNACHI Mold Inspection Agreement. Any legal document that is signed by yourself and your client should be reviewed by your attorney. Print out the IAC2 Mold Sampling Decision Chart. It's a general guide for inspectors to select which sampling device should be used and in relation to what the condition is of the building. So on the left side, vertical column, is the condition. You have visible apparent mold, or you may have no visible apparent mold but conditions that are conducive to mold growth, or you may have neither apparent mold growth or conditions. And on the top, you have all of your sampling devices. And based upon what you see or find in your visual examination of the building, you are going to use this chart to select which sampling device to use. For example, let's say you have visible apparent mold. Should you swab sample? Sure, you can swab sample or a tape sample. They're just about equivalent. It's really a matter of preference. Interior air sample? Yes. If you see a visible apparent mold inside the house, you have to take an air sample in the area of the building with the visible apparent mold growth. So the surface sampling, swab or tape, is going to confirm that what you see is actually visible mold, and the air sample is going to confirm that that visible mold is producing mold spores in the air. Do you have to take an outdoor sample? Move over to the side of the chart. It says yes. You have to take 2 outdoor samples. Ideally, you would take one windward and one leeward of the building. and the chart says, do you have to take a carpet sampling? That's up to you. It's at the discretion of the inspector. And there are many different types of carpet sampling devices actually available to you. And when you choose a sampling device, you also have to keep in mind the hypothesis that you are going to confirm or refute. The hypothesis should be answered by the type of sampling device that you are going to grab out of your toolbox. If you see visible apparent mold growth, do you have to use a wall sampling device? No. Just as your work ledger or workbook or logbook is a legal document, the chain of custody is also a legal document. Chain of custody is a very important document. It is essential to document your work when performing an environmental inspection and sampling. A mold inspection is meaningless if the work cannot be traced through a chain of custody document that identifies the date, address, sampling method, sampling location, and sampler. The chain of custody can be considered a legal document. It must be properly and accurately completed. It must be filled out legibly. An unreadable or incomplete document can be a legal liability. The purpose of a chain of custody document in relation to sampling are as follows. 1, to ensure that laboratory personnel do not lose track or exchange samples. 2, to prevent tampering with sampling devices. 3, to track mishandling that might compromise a sample's integrity. And 4, to qualify laboratory results as evidence in legal cases. Included in your course document is a sample chain of custody form from ProLab. Each sample must be marked with a unique identification number that matches in the chain of custody document. Air sample volumes must be calculated and recorded. The laboratory requires this information in order to calculate spores per cubic meter. Shipping samples to the laboratory overnight is typically preferred. The laboratory should be consulted about the proper collection and shipping methods prior to taking any samples, and this can actually be written down in the chain of custody as well. One of the sections in your course materials is the resource list. This is a great list for resources, sources of information. The top is the EPA. EPA has a lot of information about mold, and they have a lot of guides for the public. Congratulations. This is the end of your mold inspection training online video course. I recommend downloading the course materials and reviewing it and going over it again. It's a heavy, robust document. We didn't go over everything in the online video course that's in the document. So go over that, print out all of the vital documents. All of those documents are available, like the IAC2 Mold Inspection Standards of Practice and the decision chart. That's in your course document, but it's also provided on www.iec2.org website. And I recommend also having the ability to go back and replay this video, review it, play some sections, fast forward, and get a real good, confident feeling about mold inspections prior to taking your final examination. And take your final examination with a lot of confidence because you have learned a lot. Taking this course successfully and completing the examination successfully is a requirement of membership in IAC2. That's International Association of Certified Indoor Air Consultants. Consider being a member of IAC2. Visit www.iac2.org and get IAC2 Mold Certified. Again, Thank you for taking the course. Congratulations.